Hello everyone, welcome to today's tutorial on solving the merge string alternately problem on LeetCode. This problem challenges us to merge two strings by alternating their characters, starting with the first character of the first string. If one string is longer than the other, we append the remaining characters to the end of the merged string. In this tutorial, we will explore two different solutions to this problem, each offering its own insights and advantages. By understanding these solutions, you will gain a deeper understanding of string manipulation techniques, algorithmic thinking, and efficient problem solving in Python. Our first solution focuses on a step-by-step iterative approach. This solution is beginner-friendly, highlighting the core logic behind the problem without relying on advanced Python functions or modules. Our second solution introduces a more concise approach, utilizing the zip-longest function from the itertools module. This function allows us to iterate over multiple iterables in a synchronized manner, even when they have different lengths. By leveraging this function and generator expressions, we can merge the strings with elegance and efficiency. We will also explore the time and space complexities of both solutions, ensuring a comprehensive understanding of their efficiency. So, without further ado, let's dive into the world of merging strings alternately and unravel the secrets of efficient problem solving in Python. The intuition is to merge two strings by taking characters alternately from each string and building a new merged string. So here, in solution 1, we start with the first character of word 1, then the first character of word 2, and followed by the second character of word 1, the second character of word 2, and so on. And to implement this, we use two pointers, I and j, to keep track of the current positions in word 1 and word 2, respectively. We iterate through both streams simultaneously, appending the characters of the merged strings as we go. The while loop condition here, while I is less than len1 and j less than len2, ensures that we continue merging characters as long as there are more characters in both word 1 and word 2. Within the loop, we concatenate the current characters from word 1 and word 2 to the merged string using the plus equals operator. And after the loop, we check if there are any remaining characters in either word 1 or word 2. If there are, we append the remaining characters to the merged string using slicing tool word 1 sub I or word 2 sub j. And finally, we return the merged string as the output. The intuition behind this approach is to handle the merging of characters in an alternating manner while considering the length of the two input strings. By sequentially merging the characters from both strings, we ensure that we cover all characters in both strings while maintaining the desired alternating order. Now, let's go through each line of code and discuss the syntax, mechanism, algorithm, semantics, and logical reasoning behind it. This line defines a function called merge alternately that takes two input string arguments, word 1 and word 2, and returns a string. And here we initialize an empty string merged to store the merged string. Len1 and len2 variables store the length of word1 and word2 respectively. And we also initialize two variables I and j to keep track of the current position in word1 and word2, starting from the first character. And this is a while loop that continues as long as both I and j are within the valid range of indices for word 1 and word 2. Inside the loop, we concatenate the current characters from word 1 and word 2 to the merged string using the plus equal operator. Then we increment both I and j by 1 to move to the next characters in word 1 and word 2. And after the loop, we check if there are any remaining characters in either word 1 and word 2. If I is less than len1, it means there are still characters in word 1 that haven't been added to merged. In this case, we append the remaining characters from word 1 to merged using slicing tool, word 1 sub I. And similarly, if j is less than len2, we append the remaining characters from word 2 to merged. And finally, we return the merged string as the output of the function. The logic behind this solution is to iterate through both word 1 and word 2 simultaneously, taking characters alternately and appending them to the merged string. And if one string is longer than the other, we handle the remaining characters by appending them to merged after the loop. The time complexity of the solution is O of maximum len1 and len2. This complexity arises from the while loop that iterates through the strings as long as there are characters available in both word 1 and word 2. Since we are traversing at most maximum len1 and len2 characters, the time complexity is linear with respect to the maximum length of the two input strings. The space complexity of the solution is O of 1, which means it uses constant extra space. The space consumption does not depend on the input size. The only additional space used is for the merged string, but its size is limited by the sum of the length of word 1 and word 2. Since we are not using any data structures or collections that scale with the input size, the space complexity is constant. Now that we have examined solution 1 in detail, let's move on to our second solution. This solution is indeed a more concise way to solve the problem, but the reason why I didn't initially use this solution is that it involves using the zip longest function, which may require, what happened to my light? Which may require additional explanation for someone who is new to Python or coding in general. So in this solution, the zip longest function is imported from the itertools module. And this function allows us to iterate over multiple iterables in a synchronized manner. And even if they have different length, the multiple iterables in our case are word 1 and word 2. This function fills the shorter iterable with a specified fill value, and in this case, it's an empty string. And inside the merge alternately method, zip longest of word 1 and word 2 with a fill value empty string is used to iterate over corresponding characters from word 1 and word 2. The fill value empty string argument ensures that if one string is longer than the other, the missing characters are filled with an empty string. The generator expression a plus b for a and b in zip longest of word 1 and word 2 with fill value empty string creates a generator that yields a pairs of corresponding characters from word 1 and word 2. The expression a plus b concatenates these pairs. And finally, the join method is used to concatenate all the pairs of characters generated by the generator expression, resulting in the merged string. This solution is shorter because it utilizes the zip longest function, which handles the merging of characters from word 1 and word 2 in a synchronized manner. The generator expression and join function efficiently merge the characters and produce the desired output. The time complexity of this solution is also O of maximum ln 1 ln 2. This is because the zip longest function iterates through the characters of the longer string, and the time taken is proportional to the maximum length of the two input strings. The space complexity is O of maximum ln 1 ln 2. This is because the generator expression creates an iterator that generates pairs of characters from word 1 and word 2 on the fly. The join function then concatenates these pairs into the final merged string. However, at any given time, only a pair of characters is stored in memory, not the entire merged string. And therefore, the space used by the solution is determined by the maximum length of the two input strings. Both the time and space complexities are the same for both solutions, as they both involve iterating through the characters of the longer string and merging the characters into the final string. The solution 2, the second solution, achieves a shorter code length, but maintains the same time and space complexity as the initial solution. And both solutions are valid and provide the correct output for the given problem. The choice between the two depends on factors such as code readability, familiarity with the utilized functions, and personal preference. If you are a beginner or new to Python programming, I would recommend starting with the first solution. And it uses basic string manipulation techniques and follows a straightforward iterative approach. This solution is easy to understand and can serve as a good learning opportunity for beginners to grasp the core logic of the problem. On the other hand, if you are already familiar with the zip longest function from the itertools module and comfortable with generator expressions, you may prefer this second solution. After all, it offers a more concise code and utilizes a built-in function specifically designed for iterating over multiple iterables simultaneously. In general, it is important to strike a balance between code simplicity and readability. While a shorter solution may appear more elegant, it should not compromise the clarity and understandability of the code, especially when working on a collaborative project or maintaining code in the long run. All right. That's all for today. I hope this tutorial helps you in your coding journey. And remember, practice is crucial for mastering LeetCode problems. Please try solving more similar problems and gain familiarity with different techniques and data structures to enhance your problem-solving skills. If you have any questions, please leave a comment, and also please subscribe to my channel, like the video, and click the bell icon on to receive the latest updates. Happy coding, and thanks for watching. Goodbye!